Let's go back to what we were talking about. According to what we've seen so far, it's rather better to get rid of threads for the better osseointegration. But that's not appropriate either. That's because self-threading threads are the best way to control depth of fixture placement and to maintain the angle and direction of placement at the time of fixture plantation. To understand this, you need to look at the fixture placement procedure. There are two ways to plant fixture, which is tapping and rotation manner. Suppose the fixture doesn't have screw threads. In the tapping manner, if the bone density is good, you have to tap the fixture harder, so make the patient uncomfortable, and the direction of placement may be easily deviated from the normal path. Plus, if you dig the hole short, you cannot plant it to the full length. So, when you plant this tapping style fixture, you usually dig a big fine hole to the full depth. So, gentle tapping and straighter placement and full sitting is possible. However, if bone density is bad and you dig the hole as you normally do, initial fixation gets worse, so integration failure may occur. So you need an experience how to make hole different depending on the bone quality. If not, there is also possibility of it will be planted too deep because you tap the fixture. So it's difficult to control the depth of placement. Anyway, in both cases, what should we do to draw back the fixtures without the damage to the bones? It's impossible. Now let's take a look at the rotation manner. The same things might happen under the same conditions. However, at the rotation manner, you can plant the fixture by handpiece angle. So it's easier to maintain direction of placement, and fixture is less likely planted deeper than the tapping method. But although it's better than the tapping method, there is still no effective way to pull out the fixtures without the damage to the bones. Anyway, rotation manner is better than tapping manner. But if there is a self-threading threads when you use rotation manner, from the moment the fixture gets stuck to the bones, the threads penetrates into the bones, and the path of plantation is maintained so easily. If the bone quality is good, fixtures is planted automatically without pressing it down. You only need to hold the angular direction handpiece. Initial fixation is not captured at soft cancellous bones, but in the last few turns, initial fixation is obtained at the hard cortical bones. When you pull it back out, you just rotate it in the counterclockwise direction, then it will be drawn back easily due to threads. For this reason, although the threads have disadvantage of making osseointegration worse, but threads are necessary. Let's go over the disadvantage what I didn't tell you. Now you can understand well. These long pitch and small depth fixtures has disadvantage. It's difficult to maintain the direction of placement because the number of threads are too small. So we usually big hole to the full depth, and then the pressure to the alveolar bone is small, and initial fixation force is weak, so there is a possibility of integration failure. So it's favorable to plan this kind of fixture where the bone density is good. In a similar context, one more thing about the change of thread design. Those days, at the upper end portion of fixture, there was also change, increased pitch and depth of conventional fine threads, like this. People said there were also pros and cons. I think the disadvantage is if the bone quality is poor, the initial fixation force gets weak because the compression to the bones is well done by the outer wall of fixture, not by the threads. Threads itself cannot compress the bone so much as we think because it's a linear compression, not the surface compression as seen at the conventional fine threads area. As you see, numerous fine threads together make an almost surface. Therefore, even in the case of poor bone quality with relatively weak cortical bones, we can get the more initial fixation force from the conventional fine threads area than this area. I think in order to reduce integration failure, in the case of poor bone quality, it's important to obtain the initial fixation as much as possible. Let's compare the results. Even though pitch and depth increased at upper end portion, we cannot get the mechanical bond between the threads and also get the less contact with the bones more than conventional fine fixtures. Therefore, I think it's better than this. So, recent trends have moved to macro threads with much longer fixture and higher depth than before in order to get satisfactory mechanical bonding between the threads, or the only longer pitch threads plus no threads at upper end portion to get more contact with the bones. I've already made a comment about this. Let me tell you about this one. In a case of fixture with these long pitch and high depth threads, once the integration is established, you can get a better fixation force than the right side fixture definitely. However, there is disadvantage similar to the right side fixture. Plus, an additional disadvantage, it's difficult to plant it properly because of these macro size threads. So we need experienced planted control. Now let's do the final summary. Due to the structure of alveolar bone, osseointegration is bad at the medial and distal side of fixture, which means the fixture and the bones are not in contact with each other medial-distally. Moreover, surface treatment and threads make the osseointegration worse. Actually, this is the case with good bone density and not that bad. just the result of surface treatment and stress. However, if the bone quality is soft, available fixation force would be reduced almost half if I exaggerate a little. Nevertheless, we have to use surface treatment and stress because we need them. So, we dentists need to do our best to get more fixation forces as much as possible. It's the end for today, and thanks for watching. See you next time.